or the analysis of clustering using RStudio. So yesterday we have done something. We have installed few packages, and also I informed you how you can create a vector and how you can perform various operations on vector. So taking those concepts from yesterday, we will just continue the same means the cluster analysis today also, and you will learn so many things. Okay. 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 Sure, Sylvester. No issue at all. Right. So all of you, let me share my screen. All of you just open your R Studio. Okay. Here, let me open this. Okay. So here press Ctrl L to clear the console, and you can just create a file also. Click a new file, click on R script, and your code editor will be displayed, right? So here we will perform k-means clustering using R Studio. So clustering, you are very clear about clustering. So clustering means clustering is a process by which we form clusters, right? So in cluster, we put the elements that of similar characteristics or similar quality. So using K-means algorithm, we have to form cluster and we'll do all the analysis using a software that is called R programming language along with the IDE that is R Studio, right? So in order to perform the analysis of clustering, we should require a data set. So as we are working upon the sample data set, so let's continue with this, right? So you have in the code editor, just write view, and within bracket, just take a data set. Let I am considering about the iris data set. Okay. So just press click and enter. So whenever you will press click and enter, you can see the iris data set is now displayed here. How many columns? How many columns? It has 5 columns along both sides. Or this is a way, or directly you can access the sample data set. You have to write the data function. Then within whenever you will just select and click on run, you will have number of data set displayed, and from that you can also choose the iris data set. So you have to write the data within bracket iris, then again I have to write, then semicolon 2 and click on run. The same process we have started. Okay. So directly you can just view the columns along with the data sets in the variables and the values in the the first we have to for that we need the numerical values. So here you can see that these variables are a numerical type, but fifth one, that is the variable is specific, that is not a numerical type. It is one integer. It has three values. You can see here three values. This is the second value, and third values you can see this is virginica is the third value, right? So as we can see that the in the data set iris we have these four variables of numerical type, but the fifth one is a variable, right? So variable means the variables where can categorize the values in same variable in three levels. The first level is Chatushka, second level is versicolor, third level is Virginica. Okay, so as we are do you understand the why we are considering the fourth variable in the data set except the fifth one?
Yes, I do understand.
Okay, okay, sure. Okay. See, one thing I want to say that today I am at home. I have not gone to the university, so here that means I am facing some network issue, right? So there may be some network issue at any time. So I am very sorry for that. If you'll get any trouble.
Well noted,
Okay, right.
mom.
Okay, okay, okay. So that's why we can't apply k-means clustering in the factorial values. So we have to consider the numerical values for the k-means clustering, right? That means we have to form clustering using these four variables, these first four variables except this fifth one, right? So let we want to delete the fifth. That means we do not have to consider the fifth variable or the fifth column, and we want to store this up to this. That means from starting from first variable to fourth variable in another file, and we want to do further analysis upon that file only. Okay, so what will I do here? Just click on here, back,
Mom,
go here.
hello.
Yes.
The slide is not showing. I don't know whether you are presenting it because I'm not seeing the presentation.
Okay, 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 okay. Let me show again. Now it is visible, right?
Yes, it is
Okay,
showing.
okay. Yeah, yeah. Okay, okay. Thank you so much for saying me. So here we want to do what? We want to just put all the fourth variables in the iris data set in the iris one. Okay, so let me just put iris one. Okay, this is what? This is nothing but a variable. Here I want to put iris. Let me, I'm just writing the statement and you will explain me, because yesterday I had informed you regarding what is the iris one and what is the iris two. So now I will write it and you will just tell me what is the meaning of this one. Okay, see, I have written this statement. So how can you explain this statement? Anyone? Iris 1 is equal. Okay, this is equal. Iris within square bracket, that is minus 5. What is the meaning of this statement?
It means it's excluding the fifth root. The data excluding the fifth root. Hello, hello, mom. You're not audible. You are not audible again.
Everyone kindly do the same process and just inform me that you are getting the same output. Let me show you again.
Mom, the presentation is not showing.
Okay. Now this, it is not showing yet. Is it visible? Is my screen visible?
Not yet.
Let me.
Oh, it is now.
Not yet.
It
Okay.
is now. It is now showing.
Okay. 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 Now showing, right?
Yes, it is showing.
Okay. Let me. See, all of you just run this coding and just inform me that you are getting the same output. And this is the coding that you can see on my screen.
Okay.
Okay, did you get the same output here? Iris 1, this 5, iris 1, this variable consists of how many variables?
Five.
5, iris 1.
Irish one four, four rather.
Four, right? So what
Yes.
is the meaning of this one here? That I see, try to understand each and every statement, right? So what is the meaning of this statement here? Iris is a data set that we just displayed using this view statement, right? So iris is a data set that consists of 5 variables, but we are not interested in the fifth one because we do not want to form cluster using the fifth one, because the fifth variable is a factorial one. That means there is a categorical value. We have three types of values in this species column, right?
Yes.
Acetosa and Virginica and another one. Okay, so three type of categories or three type of levels are there in the fifth variable, that is species. So that won't be fruitful for us to consider that in the cluster. So that's why we want to form cluster using the first 4 variables, because the first 4 variables consists of the numerical value. So that's why we want to exclude the fifth one. So for that, we consider the negative index. So if you remember that yesterday I was talking about the vector, and at that time that I told you that is the negative index. So negative index does what? That you have to exclude the value or the variable stored at the negative index. That means I would in this statement I am saying that exclude the fifth variable, the variable stored at the fifth index from the Irish data set. So what is the variable stored in the fifth index? That is species. And after excluding the fifth index, the rest 4 variables are stored in another variable that is called iris 1. So whenever I want to show that whether this iris 1 consists of all the 4 variables, I have to view. Okay, so write view command with V in capital letter. So don't write V in small letter, that is different. Okay, so as R is gas sensitive, you have to be very much careful about writing the commands. So V will be in capital letter, view within bracket. You want to show that how many variables are there in the new file. So what is the new file here? This is Irish 1. So whenever you will just select and click on run, or either you can just click and control and enter, you can see that iris 1 consists of 4 variables. It is now showing in the environment section also. 4 variables with 150 observation, right? So everyone is getting. Am I clear up to this to everyone?
Yes, you are, mom.
Okay. Okay. So if you will see, just click on this again, because I will perform some operations. At that time you will notice the difference. Click on this iris 1 at the third panel in the environment section. You will see that the zipper length value starting from 5.1, 4.9, 4.7, 4.6, etc. Zipper length also 3.5, 3.0, petal length 1.4, etc. Petal width 0.2, etc. Okay, so if that means these values are not scaled, right? This is not a scaled value. So if we want to scale the data, that means the scaling one. So scaling means we have to bring the data into one level. Okay, that in the form of 0 and 1 structure will form that into a level. So this is the data dot scaled one. Data is scaled one. We have to bring the data into one level. So what will we do? So just write. Everyone type the same in our R Studio. I want to scale the data present in iris variable now. Okay. So iris1 variable, right? So iris1 variable consists of four columns, right? So I want to scale the values present in the fourth column. That means starting from 1 to 4 column. So how can I do that? So iris 1 is equal age dot data dot frame. Okay, age dot data dot frame. Within within parentheses, you have to write the scale function. Okay, scale function. And what you want to do, that is you want to scale the values present in iris 1. Okay, so scale function, here scale function will do what? It will bring the data present in this iris variable into a label, and we want to store that in a tabular form in a two-dimensional data set. So that's why we are writing a function. Its name is age.data.frame. So data frame is, or you can say it is a command in R programming language that is used to display the variables or the values in two-dimensional structure, that is in the form of table, right? So after scaling the data sets, data present in iris 1 variable, if we want to show in a form of tabular, that means we have to write age.data frame. That means the values will be displayed in the tabular form, and scale function will use to scale the values into a label. Which values? The values present in iris 1 variable. So after doing all this operation, we have to store the same in again this iris 1, right? So first of all, you will do what? You have to run this statement. So press Control and Enter. Then again, I want to check whether the value in iris 1 is scaled or not. So I will write here view within bracket. You have to write iris 1. Okay, just click on Control and Enter. Here you can see that as I am getting the output here, simple length it is properly scaled with 0 and 1, simple width 1 and 0, petal length same, petal width also. Okay. So before scaling we are getting 5.1, 3.1, 3.2, 4.6, etc. After scaling we are getting in a particular level, right? So that's why we need to scale the data set. It is not always necessary to scale, but if you need, you can scale the values present in a data set. Okay. So up to this, are you getting the same output? Just run this. Open your R Studio and run with me, so that you will be clear also. If you face any kind of difficulty, kindly ask me. Okay. Okay. Very good. Very good. Okay. Everyone, the students present over here, please, everyone, it's a request to run each and every program, each and every statement that I am showing, so that you will be very clear. Okay, right.
Okay,
Then,
done. Done.
okay, okay. Now up to this we have created any cluster. So now we will create cluster. So in order to create cluster, we have to install packages and we have to call those packages. And after installing the packages, those packages will help us to make use of the various functions and commands that will help us to form clusters. So that is the motto by which we for which we are installing the packages, right? So what we'll do now, we want to determine how many clusters we can form. In case of cluster analysis, we should first know the how many clusters we can form. So for that, we need few packages. Okay. So everyone, just write, just write install. I am writing this in a comment line because I have already installed. I do not have to install again. So as you have not installed the packages, so just remove the command line and write the same statement. That is install dot packages within bracket, give the double quote, that is N capital, B small, then clust, C capital, clust. Okay, so this is the package that you want to install. So here just select the entire statement, click on run, and see that NB clust package will be installed in a while. Everyone do the same process. I am writing this in a comment line because I have already installed. I do not have to install it again. Make it sure that you are putting N as capital, C as capital. All others are in small case. Okay. Okay. Did you install?
Yes, we are.
Okay. See, first of all, know the purpose of installing this package NB Clust. NB Clust is a package that available in R, that it determines the number of clusters. That means how many clusters we can form, and proposes the user that the best clustering scheme. That means which kind of algorithm should be used to get the best clustering. That means we can just use the data sets for getting the proper clusters. Okay, so that can be obtained by using the package that is NB Clust. And next, as we want to do the k-means clustering, for that we have to install another package that supports k-means clustering, that is install dot package. Write this statement within packages. Okay, this is packages, within bracket, within double quote, you have to write cluster. Okay, C cluster. So this cluster package, just select this and click on run. This cluster package is used because it supports k-mean clustering. Here we want to do the k-means clustering, so we need to install the package that is cluster. So all of you just install these two packages. Okay, done. Very good. Very good. Okay. So remember one thing. Remember one thing. Suppose you have installed a package. So at that time you have to install the package. You have to call that package. And suppose in any case you have installed a package. Okay, so you do not have to install that again. So what will you do? You will simply call that package. Okay. So if you have already installed, you have to simply call that package so that the package will be available for you. So as I have installed this NB cluster and cluster, I only have to call the packages. So what will I write here? I will write library. Okay. Library, and within bracket I will write the name of the package, that is nb clust, nb clust, right? Then run this one, control and enter. So when you will press control and enter, that means this line is executed. That means I have called nb clust package. That means now this package is available for use. Then I have to call another package that I have installed, that is called cluster. So I will write here library. Okay. Library, within bracket this is cluster. Okay. Cluster. Okay. Press control enter. Now that means I have called both the packages, that is nb cluster and cluster, right? Up to this everyone clear, everyone getting?
Yes, we are getting it.
Okay. See, here I have to find, I have to plot the number of clusters. I have to find the number of clusters. So for that, I have to use a function that is WSS plot. Okay. So let me write this statement and you see, notice that what is happening here, whether it is running or not. WSS plot. Okay. Here, see, nothing is prompting. R is not prompting is anything. So I want to form clusters on this iris1 variable that consists of four columns, and comma if I'm writing, that is NC, that means number of clusters. NC means number of clusters. Let I am giving maximum number of clusters is 15. Okay. NC is maximum number of clusters. And the clustering will start from 1, 2, 3, 4, etc. Okay. So if I will run this, it will show me error. Okay. Let me check. Okay. What is showing here? They could not find function WSS plot. Why? Because I have not created this WSS plot function. Up to this clear? So how can you create? So you remember one thing, that I have shared you something. I have shared a Word file. Okay. So at that Word file, you see that WSS plot coding is there. Just open that file. I have shared you. Okay. Here, this file I have shared. If you remember, just copy the code. This is the WSS plot, how to create the WSS plot function. Just copy the code, paste here, paste in the RStudio, and I will explain the lines, what is written and what is the need of this WSS plot. Okay, so first of all, you just copy this code and paste in RStudio, right? So make it as comment line, then paste. Okay. So now I pasted this WSS plot. Everyone, I have shared the file, and you just copy that code and paste in the RStudio. Select all the this WSS plot coding, click on run. Okay. Now you can see that WSS plot is being created in my RStudio. What is the proof? That in the environment section, you can say that WSS plot function is now they are in this environment section. That means I have successfully created this WSS plot. Right? So WSS plot does what? It can find out the maximum number of clusters you can enter, and the means the method of plotting the you can set the clusters, right? So here you can see that. Let's go to the theory portion. See this file I have shared with you. Did everyone just copy and pasted the same code in RStudio? Everyone, did you do the same thing?
Yes, we
Let's
did.
understand the statements. Yes, yes. Let's understand the statement. See, Here WSS plot, this is a function that needs to be created, right? So what is written here? Data means what? It is a parameter. You can see it is written, I have shared this. Data is a parameter, you know that this is a parameter. And this is what? This is the data set. This would be the numerical data set. If you remember that we are considering the iris data set, and iris data set we are considering this four columns, that is starting from sepal length to the petal length, four columns, and all the data in the fourth column, that means four columns, are of numerical type, right? So the data that is present, that we want to apply WSL plots, would be the numerical data set. And we are considering iris, that is iris 1, that is the numerical data set. Okay. NC is what? NC, I told you, this is the maximum number of clusters can be formed. So we are saying that NC is equal 15, that means maximum number of clusters we can form, that is 15, right? So here, this is what K means. That means we want to perform the K means clustering algorithm upon this data, this numerical data set, and the centers is equal I. Centers means the number of clusters we can form. Here I value what? If we want to form two clusters, the I value will be 2. That means centers is equal to. So in this WSS plots, what is the meaning of centers? The number of clusters we want to form. And what is this data? The data set, the numerical data set, and we want to perform the K means algorithm here. Okay. What is WSS here? WSS means this. You can see this is WSS or WCSS. That means within cluster sum of squares, or within sum of squares. That means within a cluster, we want to find the sum of squares. So what is this sum of squares within cluster? That means if we are forming a cluster, or we are creating a cluster consists of a number of points, a number of data elements. So the distance between the data elements present in a cluster is called within cluster sum of squares, that is WSS. Okay, or WCSS or WSS. Okay, here, right? And what is this seed? This seed is written here, seed. So what is the meaning of seed or set dot seeds here? So this is a function, right? Set dot seed is a function. So what is the meaning of seed? That means in case of k-means cluster, we have considered number of data elements, and among the number of data elements, we have to form a centroid, that means the middle element or the mean of the elements, you can say centroids we have to find. And each and every time we have to consider different clusters, and we have to perform the centroid, that we have to perform operations to find the centroid. So it may happen that every time whenever we do the analysis, we get different centroid. So we have to say that the results or the data sets that we are using are reproducible. So in order to do that, we have to use the function, that is set dot seed, right? So this is the function, and seed is nothing but a integer value. You can say here 1 2 3 for integer value. That means we are saying that the elements in the data set, or the elements in the cluster are reproducible. Okay. Here you know that X lab with the name of the X axis, Y lab with the name of the Y axis, and the type we are writing B. So B means what? Can you say what is the meaning of type is equal B? That means whenever you plot something, that will be in both points and lines, right? So that is type B. So if you have written type is equal L, that means only line graph will be there. Okay. So up to this clear, right? So any doubt you want to ask me anything, or I will run?
No doubts for now. They are clear.
Okay. Okay. See. Next. Okay. Next, we'll write the same statement that we are facing errors. Okay, at this statement we are facing errors because we had not created WSS plot. Now we have created this WSS plot function successfully. Now we are ready to run this statement, the above statement in the command line again. So what will we do now? See, let right here WSS. See, here our studio is prompting us the WSS plot function. That means it is already created. I want to form a cluster, or I want to find the number of clusters from the IRIS1 dataset, because IRIS1 dataset consists of 4 columns of a numerical type. So what will I do here? I will write the variable or the data set. That is, the data set is IRIS1. Okay, maximum number of clusters I can form is equal 15. That means I am saying that I can form maximum number of 15 clusters, right? Then seed is equal, here right, seed is equal 1 2 3 4. So whenever you just select this and click on run, you can see that a graph is showing at the fourth panel. Just click on zoom. Okay, so here the number of clusters at the x-axis, y-axis is within group sum of squares. That means WCSS. Okay, you can see here. This is WCSS, within group sum of squares. Within group sum of squares. Okay, so here it is what? This is the elbow method. This is the elbow method. Just remember, just listen carefully what I am saying. The entire graph is plotted with number of clusters and within group sum of squares, that is WCSS, along with the values. We have written type is equal B. That means we are getting points and along with the lines in the graph. You can see that when number of cluster is 2, this is the point. Number of cluster is 3, this is the point. This is 4, this is 5, that is 6 and 7. You can see that whenever at cluster 7, after this, you do not say that there is much more variance along with this graph. Okay, that means we can see that after 7 the change is very minor. Okay, after this 7, this is 6, this is 7, 8, 9, 10. That means very minor changes is there. So we will take 7 clusters. So this is the use of WSS plot. The WSS plot will say how many clusters we can consider. It will show you a elbow graph in the elbow structure, and you can say that at point 7, at number 7, some 7 means number of clusters here. So at number of cluster 7, after that we can see that minor change is very minor. So whenever the minor change in the graph will start, will decide that we will consider 7 number of clusters in the IRIS1 data set, right? So you can see here also from this, this is the elbow method. It is looking like the elbow of the human being, right? This is like a elbow. The graph is like the elbow. So that's why we are saying that this is the elbow method. And this shows that it is the graph. Graph is plotted along with the variables, and it shows 2 things. That is number of clusters and WCSS. WCSS is what? Within a cluster, the difference or the distance between the points. So as you can see that as number of clusters increases, here it was 1, 2, 3, 4, 5 and 6. That means number of clusters here in the x-axis it is increasing, and we are saying that WCSS is now decreasing. And here there will be a point, there will be a cluster. After that, you can see that the variance is a difference or the change is very minor. So at that point, you have to decide that this will be my number of clusters, right? You can just see the word file I have shared and just look at this. Look at the graph you now received. Okay, and see the difference. So here the number of clusters will be 7. That means we have to consider 7 number of clusters from the data set, that is iris 1. Let me just confirm that everyone is getting. Take your time, see what is within group sum of squares, what is elbow method. I have shared everything, I also explained. Okay, okay. Am I clear? Am I clear up to this? That
Yes,
means
you
first
are.
of all we have to decide number of clusters, then we will form the graph. Okay,
Yes, you are clear.
okay, 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 okay. I am just taking a data set. You can also do the same process upon another data set. Okay, so at your home, just to do the same process by taking another data set and check. You can check the result also here. That means we decided from the graph that we will consider 7 clusters, because after this the change is very minor. So up to this we have to take the clusters. So I will take 7 clusters, and this is very clear from the elbow method that is being plotted by WSS plot function. Okay, so that's the need of WSS plot. How many clusters we are taking? We are taking only 7 clusters, and it has given that maximum clusters are formed, that is 15. You can see that here maximum number of clusters are 15. Okay, so 14 is here written, and this one the 15 one. So maximum clusters formed is 15, but we are considering only 7 clusters as per our data set given, because after that we are not getting any changes, right? Then what we'll do now, I want to form k means clustering. I will explain the theory also, right? So just see the practical portion, then I will say, I will explain how means any numerical values are given, how we can find the k means clustering by your own, because this is the same process. That means the data set is given to the software, and the software or the algorithm is calculating the k means clustering analysis for us. If the data set is given to us, the numerical values will be given to us, how can we find the number of clusters? Okay, so that is the need of WSS plot. WSS plot means given, how can you form the means? Okay, iris k means is a variable. Here I want to store, I have to perform k means algorithm. So k means function is there, and upon which data set? Upon iris 1 data set, right? Iris 1 data set. Iris 1, and I have to perform 7 clusters, right? So 7 clusters. Then just click on this, select on this, and click on run, right? So whenever you will just select this, you can see that iris k means is a variable where k means algorithm is applied on the iris 1 data set, and we are forming 7 clusters, right? Here it is showing in the right hand side in the third column that iris k means, now the variable is created, it has list of 9. That means 9 attributes are there if you are performing the k means algorithm. But we are forming only 7 clusters. Cluster is different, attributes are different, right? So it is saying that iris 1 data set, if you are forming, if you are applying k means algorithm, k means algorithm is providing 9 attributes upon the 7 clusters, right? So how can we form the attributes here? So I will write attributes. Okay, this is the attributes, and within bracket we have to write the variable. The variable is what? Iris k means. So I will write here iris k means. Okay, I want to see the attributes. Then control and enter. You can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 attributes are there. Here it is written list of 9 at the third column, third panel, and you can see that it is showing that the K-means algorithm, if it is applied on the iris one data set with 7 clusters, it has 9 attributes. We can find cluster, we can find centers, we can find withinness, we can find the size, we can find the iteration, everything else. Okay. And the what is the class of these data sets? Class of this that means these attributes belong to which class? Belong to K means algorithm. So that's why it is written as all the attributes belong to the class K means, right? So up to this, any doubt? Status is total sum of squares, right? Total sum of squares. This is withinness. Okay, up to this, any doubt? Anybody is getting any doubt? Run the same coding, run the same coding. Okay. See, if you have null values, or if there is not applicable values, or if the value that is being present that is not very beneficial or for us, that means we have to write that is in case of the data set that NA is equal null. That means that the data set that we want to consider that doesn't have any missing values. So if the data set doesn't have any missing value, then only we can apply the k-means clustering, right? So let you are considering 50 elements, but two of the elements are missing or corrupted. We cannot form the clusters properly, right? So we have to just remove this null values and NA values. Okay, clear? Clear to everyone?
Yes, we are clear.
Okay, okay. Next I have to find the number of clusters. How can I find the number of clusters? So now you can see that K-means algorithm is applied to the iris one data set, and we are saying that we need 7 clusters. So everything is stored in a variable that is iris K-means. So if I want to find the number of clusters, that means whether it is 7 or not, I want to create 7, whether it is actually 7 clusters are created or not. So I have to take, I have to make use of this which kind of variable or which variable, that is iris K means. So what will I write here? That I want here, let the hashtag I am writing that we can find okay number of clusters. How we can find out? I have to write the variable that is iris k-means. Okay, iris k-means, and with the dollar symbol write cluster. Then click. Let me select this statement. Click on run, or either you can just press Control and Enter. So whenever you will press Control and Enter, you can see that total 7 number of clusters are there. That means 1, 2, 3, 4, 5, 6, and 7. That means the last value is showing as 7. That means we can form 7 number of clusters, right? Means up to 7 number of clusters can be created. Getting? This is 1, that means first cluster can be created. 2, that means second cluster can be created. This is 3, third cluster can be created. The fourth, where is 4 written? This is 4, that means fourth cluster can be created. 5, that means fifth cluster can be created. 6 means sixth number of cluster can be created. And 7, that means 7 number clusters can be created, right? That means up to 7 number of clusters we can create. Okay. Are you getting?
Yes, we are. Mom,
Ah,
Sylvester asked a
yes,
question
yes.
on the on the chat box. So if you can
Okay.
kindly check on it and then address it.
Which you want to remove in elbow method? We are taking 7 clusters. Is it because you're interested in the change? No, 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 no. See. Here you can just plot the data set. That means the data present in the data set using the elbow method. See, there are two ways of finding the number of clusters. First of all, you can find the number of clusters using a graph, or you can write manually the number of clusters you need. Okay, so if we want, see the R studio here again. I'm saying, if you want that I need 7 clusters, you have to write that I want to perform k-means algorithm on the data set iris1 and I need 7 clusters, and you will see that whether 7 clusters are created or not. This is one method. Okay, so if you want to create the 7, or if you want to do not want to write the statements that you need how many clusters you need, then you can just write WSS plot, right? So this is one method. Another method is uh, am I audible now?
Mom, yes, you are. So,
Oh,
mom, if you
I
can
was
kindly go back
yeah, yeah.
and then
I was
Yes, ma, you are
disconnected.
audible.
Okay, okay, okay. Let me okay. See, let me explain this again to Sylvester. You are writing something that nothing is there in the chart box. Okay. So you were saying that whether the elbow method, we are using the 7 clusters because it is changeable. See, there are, as I told, that there are two methods of finding the clusters. If you have the data set, that means here you can see that we are saying that we need k-means algorithm to apply on the data set iris1, and we need 7 clusters. Okay, this is one method that we are saying that yes, we need 7 clusters from the data set, that is iris1. And what is the method I want to apply? I want to apply the k-means algorithm method, right? So this is one way. Another way, if you do not want to write this manually, that the how many clusters you need, you have to make use of this WSS plot. So what is this WSS plot will do? This will make use of the and will inform that what will be the exact number of clusters by which the data will be categorized. Okay, so depending upon the different values in the data set, the elbow method, the number of clusters will be changed. It won't be similar for all the data type, all the data sets you are presenting. Okay, so this method will actually say that how many will be the number of clusters by which the data present in the data set will be properly categorized into the groups, right? Okay. Any doubts, Sylvester? Any other doubts? Yeah, I was saying this. Suppose, yes. See, I'm not. You are not audible. Anyone is not audible to me. So if you are, want to ask me anything, please mention in the chat box so that I can answer. Okay. So Sylvester has a doubt that if you have a null value NA, okay. See, we have the normalization process also, as we studied in the theory, that we have to transform the value, right? We have to transform the value. Let we are collecting the data, but we have to store the data in a tabular form to in a database, right? So we can use any kind of database. Generally, we are using this relational database here. That means the data warehouse is nothing but a database, right? So whenever we store data, we have to store the data in after transforming. That means transforming means we have to remove the null values. That means we can use there the filters. We can use there the, you can say, the protocols there, that we should only include the value that is useful for us. Or if we can say that if we will insert a particular data in a column, that data shouldn't be null, or that data should be of the same data type. That means let in the column age we are inserting the integer value. So we have to put the constraint there, that whenever we insert data in the age column or age variable, the data should only contain the integer one. It shouldn't be the character one. It shouldn't be any means, you can say, the logical values. Okay, so we have to put the constraint at that time. So if we will put the constraint, so whenever you will enter the value, suppose you are collecting the value, so it won't permit you to consider the NA values. That means, or it won't permit you to consider any other values that is not suitable for that column. Okay, so in this way also you can remove the null values. You can remove the means any value that is not appropriate for that variable, right? Okay, do not do it manually, because see, manually how can you do that? If you have a small data set, you can do that. But whenever we are just taking an example, right? So whenever you are working somewhere else, you have a large organization. That organization has from collecting data from the different departments from outside the organization. That means it can work on the huge data set. So whenever the data set is huge, we cannot remove the null values. We cannot remove the unappropriate values manually. So we have to apply some means, you can say, the softwares. We can have to apply some databases that remove the null value, that remove the unappropriate values. Okay, so in this way we can also reduce the data. So data reduction, you know, na, that is data reduction means we have to extract the important features from the data set by removing the feature that is not applicable for us, that will not be suitable for us. So in this way we can also make our data set more secure. We have to normalize the data, right? You know the various normalization forms. So whenever we normalize our data, so it will automatically remove the unappropriate values. It will automatically put a single value in our variable. It will also the put the relevant value. That means all the that means, you can say, that all the variables in the data set should be interrelated with each other. We cannot put any other variable that is not related to that data set. Okay, so in this way we can make our data set much more relevant for the application or for the analysis one. Okay, am I clear?
Yes, mom, you are.
Okay, okay. Thank you so much. Okay, so now up to this we have just formed the cluster. So is there doubt regarding this WSS plot? The number of cluster is now clear.
Yes, it's clear.
Yes, yes. Okay, so you know that which one? Which one?
I think he's saying about the normalization of the data in order to remove
Okay,
the
normalization.
null.
Yes, yes, yes. See, normalization. Okay, no issue. Okay, one class. Okay, okay, okay. see, one class I will take upon how we can remove this NA values and how we can reduce the that means the inappropriate data present in the data set. Okay, I will take one class to clear your doubt that you will I will take consider the data set. There will be null values, there will be repeated values. That means those repeated values they are not appropriate for us. Okay, so we will just remove those values from our data set. Okay, I will definitely take one class upon that. I will clear all your doubts. Okay, right. Okay. So now up to this, we have just created the number of clusters. Okay. So you remember one thing that we have considered the iris one data set that has four variables and iris data set has five variables. Okay. Remember that thing. We excluded which variable? We excluded species variable. Then my question is, can we relate the number of clusters along with the fifth variable that is present in the iris data set? We have seven number of clusters. We have excluded this iris data set fifth variable that is species. So can we map the fifth variable along with the seventh number of clusters? Okay, so can we? So this is my question, and let us see that whether I can or we can map the excluded variable with the seven number of clusters or not, right? So what can we do now? We will write table command. Table, everyone just write this table, and I have to write iris because iris had fifth number of variables, right? So which variable I'm interested in? I want to consider species. As you see that iris has five number of variables. I do not have to consider this four because I have already created clusters, seven clusters. I am interested in species. Okay, click on this, then put comma here, then see clusters. I have prepared or I have made seven number of clusters by the statement. This is iris k means dollar cluster, right? Iris k means dollar clusters because by writing this statement I can have seven number of clusters, right? So I have to write this. Let I'm writing iris k means here cluster. Okay, so let me run this, control enter. So as I am running, you can see that total seven number of clusters are there that is received from this statement, seven number clusters. And iris, the data set iris has the column species, and the species has three categories here: Setosa, versicolor, and virginica. Three categories are there, and these are the values. These are the values present. So I can also map the this table is about the comparison of the fifth column of iris data set with the clusters. That means now these three variant of species variables are mapped in seven clusters, and these are the values present over here. Okay, so we can also map. So in order to put the values in a table, we have to use this table command. Okay, so as here this output is looking in a tabular form, this is by the help of this table command or table function. Okay, up to this you are getting.
Yes, we are.
Okay, okay, okay. So we'll just proceed very slowly because you have to understand each and every statement, each and every line, what is written, what is why it is written for. Okay, so everyone, whenever you are just attending a lab class, try to understand each and every bit. It will be very useful. So if I'm writing something, I'm explaining. Okay, so if you are getting any difficulty at any point, at any line, just ask me that what is the meaning of this and I didn't understand. So I will again explain. Next, here we also check the value of attributes. That means if the attributes are given here, How many attributes are here? We have nine attributes. Okay, we have nine attributes here: cluster, center, etc. That means we can also find the value against these attributes, right? So how can we find? I have to write iris k means. Why I'm writing her iris k means always? Because I am applying k means algorithm upon the iris one data set. I want to form seven clusters. Everything, every information at the right hand side is now stored in iris k means variable. So if I want to perform any operations, I will always take this iris k means, right? So I want to check the value of the attributes. So how can I check here? I have to check iris k means, and I want to check the value of withinness. Withinness, how can I find? Dollar. Then these are the you can say these are the attributes, right? So any of the attribute you can click and you can check the value. So let I want to find the withinness. That means what is the value present in withinness in the seven clusters. So if we are forming the seven clusters, there are data in each cluster. Then what is the value in the withinness? That means how the values are related with each other. What are the values present? That means if we perform this withinness function, withinness, that means we want to find the value present among the data in a cluster. That means how what is the distance between the data present in each of the clusters. So we can find that using the statement that is withinness. So withinness is what? This is an attribute of this k-means algorithm. If we are providing, we are applying that on the iris one data set, right? So click on this control and enter. You can get here the values. How many values? 1, 2, 3, 4, 5, 6, and 7, right? So seven clusters are there. In one cluster, you are find the withinness value of the data present, and in second cluster, you are finding that means the difference or the distance between the data sets present in second cluster, that is called withinness, and third, fourth, fifth, sixth, and seventh. Okay, so for seven clusters, we are finding seven values. Okay, so withinness says what? The within a cluster, what is the difference between the values? How the values are different from each other within a cluster? That is called withinness, right? So another one I can find here, iris k means. Okay, here iris k means, then dollar. This is called betweenness. Okay, betweenness. Betweenness is what? That there are two clusters. Then we have to find the difference between the two different clusters. That is called betweenness. Betweenness means between the cluster, how in which way the values in a cluster are different from each other. Okay, so betweenness. So click on control and enter. You can find the value. Okay, so this is the value of the betweenness of the clusters. Okay, here. Are you getting the same? Any doubt?
No doubt. No.
Okay, yeah, okay. Next, see how can we plot the clusters. This is very important. We have formed the clusters. We found the values present in each attributes. Now we are ready to plot the clusters. So how can we plot? So we can make the plot also. For that, we have to make use of class plot function. Okay. So this is class plot. Okay, this is class plot function is used to plot the clusters. So what can we do? That we have prepared clusters on the data set, that is iris 1, not on iris. Okay, so iris 1, because iris 1 consists of four variables. Then I want to also plot the clusters. So those clusters are present in iris k, means dollar cluster. Okay, so if I will write this, then only I can get the number of clusters. So I have to write here iris k means dollar cluster. Okay, so this statement is to get the number of clusters, and the number of clusters are applied on which data set? On iris 1 data set. Plus plot is used to plot the clusters, right? Then I want to supply a title to the graph. Let this is main parameter. The title is graph. Okay, graph. Okay, then color is equal true. That means you will take the color. This is true, right? Then shed. Shed is equal true. Let me write. Then I will just explain the meaning of these statements. True. Then levels. Levels is equal 2. Labels 2 means we are taking only iris 1 and the cluster. That means we are taking the data set and we are taking the number of clusters. So that's why labels is equal 2. And color is equal to true means it will take the color, and set is equal true. That means it can have the value also false. So if you will give the set value as false, it will show the numbers of the cluster. That means first number cluster it will be 1, second number cluster it will be written as 2. But if you are writing z is equal true, that means it won't show us any number, it will just show us the clusters, right? Then you have to write lines is equal 0. Okay, just 0, right? Then you have to run this, right? So whenever you will run, you can see the graph. You can see the graph. Just see in R Studio, the graph is laying inside. So just count down how many number of clusters are there. You will use 7 number of clusters. Just count the number of clusters. Okay. So this is fifth number cluster, this is third number cluster, this is fourth number cluster, this is second number cluster, this is first number cluster, this is sixth number, seventh number cluster, right? That means 7 clusters are there. So level is 2. That means it is considering only component 1 and component 2. That means iris 1 data set and the number of clusters. Color is 2. That means it is taking the colors. You can see whether it is showing you. And the title of this graph, that means title of this plot is I have given graph. So it is showing graph on the top. Okay. Okay, label 2. See, label 2 means what? From this graph, you can see. Label 2, we are taking two components here. This is component 1 and component 2. That means here what? As we are plotting here the graph, we are plotting the graph here. How many variables we are considering? We are considering only two variables. First one is iris 1 data set. Second one is the number of clusters that we need. So we have two values here. Two labels means what? The cluster, number of clusters in one label, and iris 1 data set. The four variables in iris 1 data set in another label. That means as we have shown that we are plotting the graph considering the iris data set values along with the number of clusters. So that's why label is equal to.
So, mom, basically, you are saying, like in the normal plot we normally do,
See, okay,
that
Mama, their voice is breaking. Na?
that
Right,
represent
Mama, their voice is
the
breaking.
x and
I'm unable to understand what you are
and then the
saying.
y
Just
axis.
write their query in the
Are
comment box,
we
please. Please write
I'm
what you
just
want to
bringing it
ask
out.
in the comment box, please. Yeah, yeah. You are not audible properly. Actually, my network is very bad here today, right now. I'm sorry. I'm very
Okay,
sorry
I'll
for
do
that.
that.
See that here you see that yes, in the normal plotting we are saying that we have plotted something in x axis, we have plotted something in y axis, right? Yes. So here we, whenever we plot a graph, we generally need two variables, right? One is dependent, one is independent, and depending upon those, we have to plot the graph. So here you can say that in whenever we are plotting a graph, right? We are plotting these clusters. So here we have considered. Let us show you this R studio again. We have considered two things here. Label means yes, two variables we need. So how many variables are there? Two variables. That is iris one dataset is one variable, and this number of clusters is another variable. So depending upon this number of clusters and depending upon this the values present in the iris one dataset, we are plotting. So that's why we have taken the label as two. You can see here if I'm zooming the graph. Yes, I'm zooming the graph. You can see that I have received the clusters. How many clusters are there in the circle? The circle is one cluster, right? So each circle is one cluster. So here I can have seven clusters. And how the clusters are formed? The clusters consists of the data items. That means the data items present in this iris one data set. So that's why we need two variables here. As in the normal graph, we plot in x and y axis two variables. Here also we need two variables. That is iris one data set is one variable and number of clusters is another variable. So we are forming a graph containing the number of clusters. We are showing the number of clusters, and those clusters consists of the data present in the iris one data set. Right? Okay. Am I clear? Don't be confused about two labels, right? Label 2 means one label is iris one dataset, second label is the number of clusters. So depending upon those two labels, we can also form the graph. So the graph that I showed, that consists of number of clusters, that is one label, and the number of clusters are formed upon which data set? The data set, sorry, the data present in the iris one data set. So these are two labels, right? So am I clear to everyone? Okay. Any doubt till yet? Any doubt upon the today's session right now? Any doubt? Do I need to explain again anything?
Well understood.
Okay. 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 So next class is from 4:30, right? So yes, thank you so much. So 4:30 we'll join again to continue the next class. Okay. So take a rest for half an hour, then we'll join. Okay.
Okay, ma. Thank you.
Okay. Thank you. So that's done, right? record the data as per our condition, as per our requirement. Operations. So yesterday we just finished how we can find the correlation value if we have the data set, right? So we have also performed the cluster analysis in the class. In our data set we have, and we plotted the number of clusters, right? So up to this we have finished. So let's ask me that are you clear about k-means clustering that I told that we are using k-means clustering, or in the first class we used k-means clustering through the function k-means, and we also means a number of clusters. That means, so I want to know whether you are clear about k-means clustering in the theory part. Are you clear about k-means clustering? I need to explain? Okay, yes. Okay. That means a theory person, you know, right? So if you have a data set, see, today I explained that if we have a data set, we have a sample data set using the various, using this R Studio and using the package and the function that is supported in the package, we can find the number of clusters. We can also plot. Okay. So if we have a data set, let I have a data set present or numerical data value is present, we can also manually find the number of clusters and the value present in the number of clusters, right? Yes, a brief recap. Okay. See, just see the file that I have shared to you, or let me share my screen so that you can see also. Okay. So this is the file that I have shared to you, and you can see that elbow method that I explained in the first class, right? The elbow method. So using this elbow method, we can find the number of actual number of clusters, so that our data set that we have considered, all the values in the data set can belong to the clusters. Okay, so we can find this elbow method to WSS plot. So before going to K-means algorithm, let me explain few things regarding this WCSS. WCSS means within cluster sum of squares. That means if you are forming a cluster, what is the distance between the points in a cluster, or how the points in the clusters are different, or how they vary from each other. Okay, so that is called WCSS. You can see if you are seeing the clusters, the distance between the cluster. Okay, if we are considering a cluster, the distance between the points in the clusters may be smaller one, that means maybe minimum one, or it can be maximum one. Okay, so it is not in our hand that we should minimize the distance, we should maximize the distance, but we will try to keep that shouldn't be minimum, shouldn't be maximum. So, so this is called WCS, that is the distance between the points in a cluster. To this I have explained. See here, let I have taken observation 6. That means I have considered 6 observations, right? So let I have considered the name of 6 countries. So if I form cluster, I will have 6 clusters. Okay. So if I have 6 clusters, so in each cluster there is only one point. That means only one observation is there, or only one country is there. So if I have 6 clusters, so each cluster there is only one point. That means only one country is there. So that is called WCSS. Why? Because each cluster vary. Because in each cluster, the number of element is only one country or only one observation, right? So WCSS is 0. So here we can see that if we have a number of observations 1 million and we are forming 1 million cluster, so what is the WCSS there? Or that is already 0, because if we have 1 million observations and we are forming 1 million cluster, so in each cluster there is single observation. So if there is single observation, that means what is the distance between the cluster, between the elements in the cluster? 0. That means only single element is there, so we cannot say that there is any distance or any variance. Okay, so WCSS is 0. let me share again. So the elements the okay, so that should be low, that shouldn't be minimum, or that shouldn't be maximum. Okay, so we have to form the cluster in such a way that that shouldn't be the same number as per the observations or single number as per the observation. The cluster should be small one, so that the all the data or all the observations in the data set should fit into the clusters, and WCSS, the variance between the data points in the cluster should be low. Okay, so in this way we have to form the cluster. By which we can form the number of clusters. Okay, so let's see the k-means clustering algorithm or k-means clustering method, that how we can form cluster if we have bunch of elements and we have to apply k-means manually. Okay, that means if you are in the question was given that these are the data sets, similar data sets we have, and how can we form the clusters if we have uh, k-means clustering we want to apply, right? So I am audible. My screen is visible to everyone. So net,
Yes, ma, you are audible.
yes, I am facing very I mean so many issues regarding the network, so I am just disconnecting frequently. So share the screen again. Okay. Okay. See. Okay. See here that now everything okay. Perfectly, I'm audible perfectly. My screen is sharing. That means my screen is visible. Everything is okay. Please let me confirm that
Yes,
I
it
can
is
proceed.
visible.
Okay. Thank you so much. See that we are using k-means clustering, right? We have the data points as this much. So I'm just giving a brief regarding that how we can form the k-means clustering. After that, we'll do proceed towards an example through R Studio, right? So these are the data points. So how can we find the clustering? Means we will form the data elements, or we will make a cluster in such a way that the distance between the elements present in a cluster should be smaller one, right? That means if there is a group, there is a cluster, that means the elements if belong to that cluster, the elements should have of similar characteristics. So we'll put the elements in such a way that the variance should be minimum. So if the variance should be minimum among the data, then all the data should be placed in that in a cluster, right? So we will find the distance. So the distance between the elements in a cluster can be find out through Euclidean distance. So remember this one, Euclidean distance. We will just see it. Then, for example, if you have the data set, these are the data set, just arbitrarily choose any point as the initial cluster centroid. So M1 is the let we have to form two clusters here, that is one and second cluster. So I have to form two centroid, that is M1 and M2. So what will be the value of how this 4 and 11 is there? So at the first case, at the first trial, just take any value arbitrarily as the centroid of the data sets if you are using the k-means algorithm. Okay, so late I am taking 4 as the centroid of first, that means first centroid, and the second centroid is 11. Okay, so this is that I am taking as per my wish. So you can also take any other values, right? So here it is written that initial centroid is 4 and 11, right? So as these are the centroid, that means the middle points, these are the data elements present over here. I have to find the distance of these centroid, distance of these elements from the centroid. So regarding the value of the distance, we found according to that, according to the minimum distance, we have to form the clusters. Okay. So here we have to put, we have just prepared a table. Here first column is data points. The data points we have just be written, and distance to M1 and M2. What is M1 here? The initial cluster centered. M2 is the initial cluster centered. Why I have taken two values? Because I want to form two groups. So if you want to form three groups, you can take another centered also. So here the data points are given. That is two. This starting from 2 to 25, and I want to find the distance. So how can I find the distance here? Using the Euclidean distance method. So what is the formula here? If I want to find the distance from x2 to x1, I can find x2 minus x1 square to square root. So if I want to find the distance from 4 to 2, I can see that 4 is x2 and x1 is 2. So I will write here 4 minus 2, that is 2. Square of 2 is 4. So if I find the square root of 4, that will be 2. Okay. So in this way, I can find out the value. So whenever I put the values, the distance of M1 from 2 is this one. Distance of M2 from 2 is this one. What is M1 here? 4, M2 here 11. So these are the distance that I received, right? So up to this clear?
Yes.
Okay. Let's see. So if we have found the distance, how can we form the cluster? So as we have considered two centroid, we have to form two clusters here. So as per the minimum distance. So as we can see that M1, the distance of M1 from 2 is 2, and distance of M2 from 2 is 9. So which one is minimum here? Minimum is 2. That means this second point belong to cluster 1. For M1, we are giving the cluster C1. For M2, we are giving the cluster as C2. So as we have two centered, we are forming two clusters, that is C1 and C2. And if the value of M1 is minimum, that means this data point, the distance of this data point 2 from M1 is minimum. Okay. So now this point 2, this 2 will belong to cluster C1. So for this here, 4. So if we are finding the centroid M1 distance from 4, it is 0, and M2 distance for 4 from 4 is 7. So which one is minimum? 0 is minimum. So data point 4 will belong to C1. Likewise here, you can see that here the 10, okay, 10 is the element, 12 is the element, 3 is the element, 20 is the element, 30. So in this way you can also form the clusters, right? So here you can say that we are forming two clusters here, C1 and C2. The elements are 2, 4, 3, and the elements are 10, 12, 20, 30, 11, and 25. So from these, we have to form, see here that whether I have just formed two clusters, but all the elements doesn't belong to every cluster, right? So C1 consists of three elements, C2 consists of these elements. So I have to proceed further to form that whether any other element should belong to C1 or C2 or not. Okay, I want to see that. So I have to find the clusters again, sorry, the centroid again. So how can I find the centroid? I have to add these three elements divided by number of elements. So C1 consists of 2, 4, 3. I will add these all three, divide by 3. So it will get 4. And for C2, the elements are this much. I have to add all these elements divided by number of elements. I will get 11 here. Okay. So the cluster that I received in the first case, This is the cluster I received in the first case, that is C1, C1, C2, this much. Okay, so these clusters, these, now we can say that we have taken the data points here. We have taken the centroid as 4 and this centroid as 11. So we have to find the distance of M1 from 2 and the distance of M2 from this 2. Okay, so we can find out here. You can see whenever we'll find the distance, we can say that the cluster that we have received in C1, C1, C2, C2, that means the previous clusters will be considered here. Okay, you can say that here we have formed the clusters as C1, C1, C2, C2. That means these elements belong to cluster C1, these elements belong to cluster C2. Okay. So after that, we have formed the initial, that means the centered again, that is 3 and 18, right? 3 and 18. So whenever you form the centered again, the current centered is 3 and 18. So whenever we'll find the distance of these points from the centered from M1 and M2, the values will be 1 and 16. Okay, 1 and 16. Which one is minimum now? 1 is minimum. That means these two will belong to cluster C1. So the new cluster is C1. This is what? This is the old cluster that is carried from the previous observation. So the previous observation, when the centroid was 4 and 11, these are the clusters. So this is the old cluster. Okay. So that old cluster is written here in place of cluster, and the cluster we are forming, that is in the new cluster. So as per the centroid, that is 3 and 18 right now, we are getting these values for 2, 1 and 16. So 2 will belong to this C1. Okay, this is the old cluster that was derived from the previous table, that is C1. So now we are getting the cluster as C1 again. Okay, so this is okay. Then if the data element is 4, we are subtracting from M1 and M2. This M1 value is 3, M2 value is 18. So we are getting the point 1 and 14. So which one is minimum? 1 is minimum. So 4 belong to C1. So now our new cluster is C1. That means C1 cluster contains this 4 again and 2 was before. Okay. So C1 cluster contains 2 and 4 up to this observation, and this is the old cluster. Okay, so when in the previous observation we have seen that C1 cluster also contain this element 4, now from our current observation we can see that C1 cluster also contain the variable or the data point 4. Okay, so up to for this 10 also we'll consider. So in the previous our example, previous observation, this 10 belong to cluster C2, but now, in the current observation, we can see that if the centroid is 3 and 18, we can see that element 10 belong to cluster C1. So up to this, you have to find out. Okay, so this is the new observation. That means cluster 1. 2 belong to cluster 1, 4 belong to cluster 1, 10 belong to cluster 1, this 3 belong to cluster 1. See, 12 belong to cluster 2, 20, 30, 11 and 25 belong to cluster 2 as per the current observation. And as per the previous observation, when the centered was 4 and 11, the C1, that is cluster C1 contains 2, 4, this 3, and the rest of the elements belong to cluster 2, right? So here we have to see that whether the new and old clusters are equal. No, their data point 2 belong to C1 previously, now it is belong to C1 again. That means it is okay. Same here also okay, but this is not okay because 10 in the previous observation it was in cluster 2, but now it is in cluster C1. That means 10 is moved from C2 to C1. So there is the difference, there is the variance. So we cannot stop our observation. We have to proceed further so that we can find that how many number of elements actually belong to which clusters, right? So we will do what? We will again take the centered by taking the elements in the clusters. Okay, so C1 consists of 2, 4, 10, and 3. this one, C1. Okay. C1 consists of 2, 4, 10, and 3. And C2 consists of 12, 20, 30, 11, and 25. So these are two clusters and these are the elements. So as we know that all the elements, the here element 10 has moved from C2 to C1. There is a variance. It doesn't belong to C1 in the previous cluster, but it now belongs to C1 in current observation. So 10 is now moving. So we cannot actually say that 10 belongs to which category or which cluster. So we have to do further analysis. So here C1 cluster, this consists of these elements, and C2 cluster consists of these elements. So now we'll form the centroid. So add the number of elements, add the number
Mom,
of
your
elements,
voice is
C2 plus
breaking.
or plus
The
2
network
plus
is not
3.
stable.
Was breaking? Okay. Okay. Yes, yes, Anas. Okay. Tell me where can I start? Up to what person my voice was very clear? Am I clear to everyone now?
Yeah, it is not
Now the
clear.
voice is clear.
Now clear. Okay. Now clear. Okay, right. Okay. Shall I explain again? Do I need to explain again from the beginning of
Yes, ma.
K-means
Yes,
algorithm?
yes.
Okay, 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 okay. See. Okay. Uh, Let me explain that these are the elements, right? So these are the elements I want to apply. K means clustering to form the clusters, and in a cluster I want to know how many elements belong to those clusters. Okay. And in a cluster, if we are forming a cluster, few elements are there in the cluster. So we should be clear that the element, the distance or the variance between among the elements present in a cluster is minimum. That should be smaller one. Okay. So the distance or the variance between the elements in a cluster can be found out through Euclidean distance. Okay. Up to this, am I clear? Clear?
Yes, ma.
Okay, okay.
Yes.
So if I want to be audible, please tell me at that time, so that I can just check my network. Okay. So from the number of elements in the first trial, you have to form the centroid, like the center element. Okay. So let in my first observation, the first centroid is 4. I have taken any element arbitrarily. You can choose anyone also. Let M2, another centroid I'm forming, the element is 11. So let I'm considering the initial cluster centroids are M1, that is 4, and M2 is equal 11. So these are the centroid, right? And I have to prepare a table that consists of the number of data point that we have. So in our example, we have these number of elements, right? And I want to find the distance of the elements present over here from the centroid. So depending upon the minimum distance, I have to find the clusters. So in a cluster, I will put those elements. The elements should vary minimum, should have minimum variance among them. Okay. So the distance from centroid to the elements I will find out here. So let I will see that how can we find the distance? The distance can be through the Euclidean distance. So this is the formula of the Euclidean distance. So if I want to find the distance between x2 and x1, I have to write x2 minus x1 square of this, then I have to find the square root, right? So here I want to find out that if it is my centroid, my initial centroid is 4 here. M1 is 4, right? I want to find the distance of M1 from 2. The data point is 2. What will I write here? 4 minus 2. The square is 4 minus 2 is 2. The square of 2 is 4. So the square root of 4 is 2. Now, so here the value is 2. The Euclidean distance from M1 to data point 2 is 2. So same formula you have to apply, that M2 is 11 and data point is 2. You have to apply the same formula, right? So you will get the value as 9. So you can see that here the which one is minimum one? This here 2 is minimum. So this data point 2 will belong to cluster C1. If M2 will be minimum, the data point will belong to cluster C2. So in this way, we can see that we have formed the elements that if the centroid is 4 and centroid is 11, we have formed that C1 cluster and C2 cluster, because as we have considered about two centroid, we have two clusters. So first cluster consists of these three elements, second cluster consists of these of the elements, right? So these are the clusters. So cluster is C1 and C2. So as you can see that here we cannot properly determine that exactly three elements belong to C1 or exactly these of the elements belong to C2. So we have to do further analysis. So we have to find the new centroid of the elements, right? So whenever we find the new centroid, how can we find? So the elements, we have two clusters here. The elements are 2, 4, 3. Okay, so I can find the centroid of this first cluster as 2 plus 4 plus 3 divided by 3. Okay, you have to add the element divided by number of elements. So when you will add this element divide by 3, you will get m1 as 3. And you have to add these elements divided by the number of elements, you will get m2 as 18, right? So here what we will do, that m1 value is now 3, m2 value is now 18, and these are the data elements we have. And we have to find that whether the distance from of data point 2 from m1 is minimum, or the distance of data point 2 from m2 is minimum. Okay, so as per that we have to see that whether data point 2 will actually belong to cluster 1 or cluster 2, right? So here how can I find? Okay, I can find out through the Euclidean distance. Same formula I have to use. That means 3 minus 2 square, the value that I have to find the square root. So after that you will get the value as 1. And same method, this method you have to apply on M2. You have to find the distance of M2 from 2, and the value will have 16. So which one is minimum here? 1 is minimum. That means data point 2 belong to cluster C1. So as per the current centroid, we are getting the clusters as this. That means 2 belong to C1, 4 belongs to C1, 10 belongs to C1. And this is the cluster that we have received from the previous observation, where the centroid was 4 and 11. So this cluster is now written here. Okay, and this is the new observation that we received as per the centroid, right here. So you can see that the data point 2 previously was belonging to cluster C1. Now also it is belonging to C1, so it's okay. You can see here same, here same also, but there is the variance here. Data point 2 in the previous observation, it was in cluster C2, but now it belongs to C1. That means here we did what? That 10 is moving its position from cluster 2 to cluster 1. So there is the variance. So we are not sure that 10 will belong to which cluster. So we cannot say that 10 will belong to C2, or we cannot say that 10 will belong to C1. So in order to avoid our confusion, we have to do further analysis, right? Further analysis. So here we have to find M2 as 18. So we have to find the centroid again. So how can we find the centroid? By adding the element divided by number of elements, and same here also. So M1 will get 4.75, M2 will be 19.6. And this whenever we'll do observation according to M1 and M2, we'll find the distance. This new cluster will be in the old cluster column, and we have to find the new cluster. Okay, remember this thing, this is very important. If in the previous observation you have find the new cluster, if you will do the further analysis, this new cluster values, this C1, C2 will be placed here in this column. And as per the new centroid, you have to find the observation, find that these points belong to which cluster, and those clusters will be written in the new cluster column, right? This will be the points. Okay. So when the centered was 4.75 and M2 was 19.6, see that we have to find out the distance of M1 from 2, M2 from 2. And we received that 2.75 is the distance, 17.6 is the distance of M2 from data point 2. And which one is minimum? 2.71. That means data point 2 belong to C1. Previously, it was also belonging to C1. Same thing we have to find out. Okay, we can see now that C1, that means it is okay. 2, previously it was belonging to C1, now it is also belonging to C1 cluster. Here same. But in case of 12, earlier it was in cluster 2, now it is moved to cluster 1. And here also 11, earlier it was in cluster 2, now it is moved to cluster C1. Okay, so now there are two elements that are more confusing, that whether 12 and 11 will belong to C2 or they will belong to C1. So in order to clear our confusion, we have to do further analysis. So up to this, we received that C1 consists of how many elements? Is 2, 4, 10, 11, 12 and 3, and C2 consists of 20, 30 and 25. So according to that, we have to find the centered. And remember that this new cluster, whenever we'll find the new center distance, will be in this column, and we have, according to the current centered, we have to find that these elements belong to which cluster. So this will be our new cluster, right? So this is the previous observation clusters, and these are the elements. So currently we received the new centroid as 7 and 25. So as per the Euclidean distance, according to this formula, we have to find. As you know that the element is value 5 is small, smaller one, then we can say the data point 2 belong to C1. Here minimum is 3, so we can say the data point 4 belong to C1. So likewise we can find out. And here you notice, did you notice anything? That you can say that all the elements 2, 4, 10, 12 up to this, as per our observation, they are belong to C1. That means cluster C1 consists of 2, 4 these elements. Cluster C2 consists of these elements. That means previously 2, 4, 10 and this 11 and these 3 belong to C1. Now they are also belonging to C1. 20, previously it was belonging to C2. Now it is also belonging to C2. 30, previously it was in C2 cluster. Now it is belonging to C2 cluster. That means everyone is same. You can see here. Previous cluster value is now similar to the new cluster value. That means whenever we see that the elements previously belonging to any cluster and on the current observation, they are also belonging to same cluster. Everything is same. There is no difference. We have to stop the observation. So now we will stop the observation, and we concluded that we have two clusters C1 and C2, and the centroid is 7 and 25, and cluster C1 consists of these elements, cluster C2 consists of these elements. So this is called K-means clustering algorithm. Okay. So that means in our exam, if it will come, you can also answer in this way. Okay. Anything you want to ask? Okay. Am I clear to everyone right now? See, today in the morning, I was in the first class, not in the morning, in the first class, I was just saying that seed this method. You can see also, uh, which one? This seed. That means set.seed, this method. This is used for what? As we know that as you see right now that whenever we are performing k-means clustering algorithm, we are getting different centered, right? So each and every time we got the different centered. First time it was 411, then became 318, then become 4.75, 19.6. That means each and every time centered is changing, right? But centroid is changing, but the element, the data sets, we are the elements in the data set, we are using those elements. Okay, we are not changing all the elements. Okay, so set dot seed function will say that the elements we need to consider from the data set are reproducible. We can use the same for further analysis also. So for this we are using set dot seed function. Okay, now you can be clear that what is the purpose of set.seed function. Okay. Am I clear now? Do you want to ask me anything? Am I clear? No question. Okay. Okay. See, let's proceed. I just explained few that means what data set was I was taking that at that time I was just performing various analysis on the data set, and we are finding the number of clusters, also plotted that. Okay, so we can also use other functions to plot the clusters also, right? So in previous class we have taken few packages, installed few packages, also use the functions that is supported by the packages, and we also plotted, right? So same data, that means same clusters. We cannot say the number of clusters will be same, because as per the data set we can also vary the number of clusters. So we can also form the number of clusters, various number of clusters, and we can also perform various other operations through few means the packages, right? So we have to use different functions in different packages, and we can also make clusters, right? So let's see that how can we do that. Just open your R Studio. So this is all about the first class. Okay, so just you have to take new file. So click on the new file, click on R script, and clear your console. So Control L will clear the console. Here in the fourth panel, just click on this clean all plots. Okay, click on this yes. And here in the environment section, just click on this clear objects, then click on yes. Now everything is okay, everything is clear for you. So I have to make cluster. I have to do cluster, or K means clustering, but using different packages and different functions. Okay. So you can do K means a clustering analysis on the data set through various ways. We cannot say that there is only one method, there is only one package through which we can analyze the data, we can form the cluster. There are so many packages, so many functions available, and so many methods are there using which we can also form the clusters, right? So let's take another example. So you have to install, go to the code editor, you have to install few packages. Let just type in your code editor portion, that is install.packages. Within bracket you have to install starts. Okay, starts package. And let's check it. Click upon this, that means just select this statement and click on run. So if the starts package is already in use, you do not have to install again. Okay, so just leave that and install the another package. So let the another package is install.packages. Within bracket you have to install dplayer package, right? Then again you have to install the another package that is called ggplot2 package, and you have to install another package that is called install.packages, and that is gg45 gg45 package. Okay, right? So these packages you have to install. So if you have installed the package, do not install it again. You have to call the packages. So we have to load the required library. That means we have to call the packages, right? So just keep all the statements in the comment line. Yeah. Okay. Call the libraries. Okay, if you have already installed, then call the library. Yesterday I was saying about to install the packages. So if you have done with the installation of packages yesterday, then just call the libraries. Otherwise, you have to select each statements and you have to click on run. Or directly after the end of the statement, you have to press Control and Enter to run the statement, right? So you have to call the library. So library, that means we have to call the packages. So the first package is starts. Press Control and Enter. That means we have called the starts library. That means starts library or starts package is now available for us. We can also use the functions available in starts package for our purpose. So let I have to call another function, another package that is called dplyr. dplyr. Okay, so I have to press Control Enter. That means this dplyr package is now called, and it can do intersection. It can have set difference, set equal, union function, union operations can also be performed by this. Okay, so that's why it is showing all these things, that these are the operations that can be performed if you are installing this dplyr package. Then we have to call library, which package I want to call, that is ggplot2. So ggplot2 package is used to plot the data element that we have in the data set. We can plot. Then we have to run this Control Enter. Okay. So after that we have to call another function, another package that is called gg45 package. Okay. Control Enter. That means now these two are for plotting purpose. ggplot2 and ggg45, these are for plotting purpose, and the starts and dplyr, these are for data manipulation. Okay, we can do various operations on the data set, and we can also plot those data sets using these four of the packages. That means number of functions or number of commands will be supported by these packages. So in order to use those, we have to call the packages. So now we call the packages. So always call the packages after installation. Okay, so first of all you have to install, then you have to call. So either you can write the require function, or you have to write the library function to call the packages. So make sure that before calling you have installed the packages. Okay, so up to this clear. Any doubt? Any doubt?
No doubt.
Everyone just installed? Okay, everyone just install the packages and just call the packages. Okay, make sure that if you know that you have installed the packages, and try to call the packages to ensure that you have already installed, because if you have installed the packages you can directly call, or after calling if it is showing you error message, that means you have not installed the packages. Okay, this is the trick. Okay, that's I told that I told to yesterday in yesterday class. I just informed to install the packages. So if you have installed that, just call these packages. So use the library function to call the packages. Okay, sure, right. Then we have to do what? We have to view the iris data set. So always write V in the capital letter. So view, this is iris. iris dataset. You can see here it is showing me iris dataset consists of five columns with the number of variables or number of values, right? So iris. Okay, so just press control and enter. You
Your
can
voice is
see
not
that
clear.
yes. What you want to ask me anything? Are you asking me something?
Uh, no, the voice was breaking, but it's now okay.
Oh, okay, okay, okay. See, this is the value. Okay, these are the values of iris dataset that we repeatedly get this value because we are just working upon this iris dataset. Okay, right? So just go to back here. Now you can see that the iris data set that we show from the table that it has five columns, right? So five columns we have, but we know that the cluster analysis that I explained in the first class, it will work upon the numerical data set, right? It won't consider the factorial value. Factorial value means the values that belong to particular that form a category or form a label. So you know that in the species column, it is forming a label. There are three values that is Setosa, Virginia, Virgicella. That is that like these three species are there. Three variants are there. So those are forming a factor. So we don't consider the factorial values for the cluster analysis. We are only bothered about the numerical values. So what we'll do that we have to select all the variables or all the columns except the species, and we'll store the variables or we will store all the fourth columns in another data that we did the in previous class. So how we can do that? I have to write my data. This is a variable where I want to store the columns from 1 to 4 of the iris data set. So what will I do here? I will write select command. The select command will select the elements or the column that I want to specify from the data set. So which data set I want to take? That is iris data set. It has five columns. Okay, five variables. But I am interested in only four. So I will write here 1, comma 2, comma 3, comma 4. So this is what? This is a vector, right? This is a vector of numerical value. Yesterday I told, so it will consider 1, 2, 3, 4. That means the value present at first index. That means first index consists of one column, second column, third column, and fourth column value will be considered from the iris data set, right? So let me just press Control and Enter. So as I can say that in the third panel, you can see that my data variable is now created. My data object is now created. It has four variables, right? Because I have taken 1, 2, 3, 4 up to four variables I need. I have to exclude the fifth one that is species. So I excluded that. So my data, this variable consists of all 150 observations with four variables. If you click on this, you can see that it has just excluded the species and considered all the rest of the four variables up to 150 observations, right? You can see that 150 observations are there, right? So up to this clear. So what we can see that in K means cluster analysis, the analyst determines the number of clusters, that is K. K means what? K is the number of clusters. If we are considering two, that means two number of clusters we have. If we are considering seven, we are seven number of clusters we have to form. So we have to group the data available in the data set. Here the analyst will determine the number of groups or a number of clusters, right? So we for that, what we'll do, as we studied in the first class, WSS plot is used to choose the maximum number of clusters. Okay, that is NC. NC is what? The maximum number of clusters. Okay. So there is WSS plot is not associated in our by default, right? So we have to create the WSS plot. So for that, as I shared you the file, just click on that, click the WSS plot, copy this and plot in the R. Okay, in the first class also I explained what is the meaning of WSS plot and what are the things that is written within this WSS plot. This is used to choose the maximum number of clusters and the number of clusters we can have, and we can also plot. We can also find the elbow method, and this plot will give us the elbow method that we can determine the number of clusters, right? So what we'll do here, we have to select this, click on run. So you can see that WSS plot is now created. This function is now created. This is what? This is simply a function, right? So this WSS plot function is now created. Okay. So type is written as same. Type is B. That means both points and lines will be plotted whenever we plot the elbow method. That we will plot the graph to know the elbow method, right? So here we can see at the environment that section the WSS plot function is available under this section. So in order to choose a number of clusters, we have to use this WSS plot in our dataset. So how can I do this? I have to write WSS plot. Then which data set we have? See here that I have selected four columns from the iris data set and I have stored that in my data. So now my data consists of all the four columns, so that those columns will be used to form the clusters. So if I want to form the clusters, I will
Hello,
consider
Ma. The
the
voice is
my data.
breaking.
My data. Oh, voice is breaking. Okay.
Yes.
Now clear? Now clear? Am
Yes.
I
Yes.
clear?
Yes.
Okay. Okay, see. Let me explain again. Okay. So here you can see that we have selected four columns, right? Four columns from the iris data set, and we have kept all these four columns in my data set object, right? So if I want to form clusters, I have to use this WSS plot function in my R Studio. So this WSS plot function will act upon my data set instead of iris data set, because iris data set consists of five columns, but we cannot form clusters using the species variable, because that is the factorial one. Okay, that is in the form of label. So we have just extracted four of the columns from the iris data set and put that in my data. So I can use WSS plot on this my data object to find the number of clusters. So what will I write here? I will write my data. Okay. So whenever I just press Control and Enter, I can see the elbow method, same elbow method. Okay. Let me zoom this. Click on the zoom option in the fourth panel and just say me what will be the number of clusters according to the elbow method. Okay, what will be the number of clusters as per the elbow method here? Can anybody say? So this is the elbow method. This can be obtained through WSS plot, that is used to find the number of clusters through the elbow method, and this consists of number of clusters. So maximum number of clusters in WSS plot we have specified, that is NC is equal 15. So that means up to this
15.
15 clusters are there, and this is within groups sum of square, that is WCSS, right? So in this cluster, what is the difference of the elements present in this cluster, and what is the difference of elements present in this cluster and this cluster also? Okay, so these are the values, right? So from this diagram, can anybody say that according to the elbow method, what is the number of clusters?
It's 15.
See your,
It's
see
five.
your, it's five.
15.
It's five. From 5, there is no much changes.
I need answers from everyone. That Semi, 14. No, no, not 14. See, we have to always make the clusters smaller, not minimum, not maximum. That I told that WCSS shouldn't be zero, it shouldn't be maximum. Five. Anas is saying five. Okay, others, please see your graph. Okay, see the graph. See this graph. Okay, this is the graph that you obtained through WSS plot. Tell me the number of clusters from the elbow method. This is looking like elbow. This is looking like elbow. And you have to consider the clusters. If after that the values are not changing, there is not much more variance, you can just stop that and stop at that point and say that these are the number of clusters. Yeah. Okay, five. Others, please try to answer. See, it may be approx. We are not here to properly analyze, right? From the graph, you cannot properly measure that this is the exact one. But this is the way through which we can have. So you say the approx one, but do not say the minimum, do not say the maximum one, because we have to consider the number of clusters smaller. Okay, so you can say that it can be five, but it can see that if you consider from four to five, this is five, right? This is five. If you consider from four to five, that means there is not much more tailedness, not much more tailedness. That means there is we cannot say we will get much more difference from four to five. If you consider from three to four, there is also not much more difference. But if you are getting from this one to two, there is a gap, a huge gap. Okay, so from 2, we cannot say it will be 1. It cannot be 1 because huge gap is there, right? So you can see that after 2, you can just take the approx one, because here from the graph, as per our observation, we can see from the graph that if after 2, we can see that we are not getting much more difference, like smaller one, smaller, 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 smaller. Okay, so after 2, we are not getting much more difference. So we can say, okay, I'm not confirming that it will be 2, it can be 3, it can be 4 also. But we have to take the most suitable one, because after 2, we are not getting much more difference. This is a smaller tail, smaller, smaller, smaller. Okay. So the number of clusters we can form, that from the graph, it can be 2. It will be suitable for the entire graph. So not 7. See, if you are saying it's 7, here 7. Can you see much more difference from 6 to 7? Can you see much more difference from 5 to 6? Can you
No.
say that if I suppose Sylvester is saying 7, another student will say that no, it will be 8. So can you say any difference from 7 to 8? Is a slight tilde is there. Okay, slight. That means minor change. We cannot say the huge difference, light from 1 to this is the huge gap, right? Huge gap. So it cannot be 1, not at all possible. Okay. From 2, you can see that smaller tailedness is there, smaller difference is there, smaller difference up to this. Okay, so the point at which you are getting you are not getting much more difference, at that point you have to stop and you will say that yes, this can be the number of clusters. So from the 2 we can say that the number of clusters from point 2, we can see the number of clusters will be 2, right? So 2. So as per the ALBO method that we received, that we confirm that the from for the entire data set we can have 2 number of clusters, right? 2 number of clusters. Okay. This is one method, ALBO method. Another one using k-means. Okay, up to this we have not applied. Using k-means, we can have also specified that yes, for my data set, I have to use 2 clusters. Okay, so how can I do? I have to allow, that means I will write a variable km here, and I will apply k-means method, k-means method upon the data set. Which data set I want to take? I have to consider my data. Okay, this is because this consists of these 4 columns. So what will I write here? I will write my data. How many clusters I want to form? I want to form 2 clusters. Which method I have to use? I have to use k-means algorithm. Okay, then I will do what? I want to print what? This variable, that is km. Then select all these, click on run. So whenever you will click on run, you can see that, see, K means clustering with 2 clusters. We have formed 2 cluster, and the size of 2 cluster is 97 and 53. That means in one cluster the element is 97, in another cluster the element is 53, because we have total 150 observations. Like cluster mean. Cluster mean means we have considered 4 variables: sepal length, width, petal length, and width. So 4 columns we have, and for one cluster we have formed the 2 cluster, right? So for one cluster we have received the minimum or the mean, not minimum, that is the mean of all the values present in the sepal length is 6.30 something. And for cluster 2 we have received the mean of the values present again the sepal length is this much. Likewise for this. Okay, here. Then clustering vectors. So how many clusters we have? 2 clusters. So we have one, we have two. If you can remember that in previous example, in the previous class, we have received 7 clusters. So it was showing 1, 2, 3, 4, 5, 6, and 7 number of elements in the vector, right? So this is the clustering vector. So as per your number of clusters, it will show you the clustering vectors. Okay. And here the components means it has how many components? 9 components, because k means method or k means algorithm always consists of 9 attributes that I explained in the previous class. So it has cluster, we can find the number of clusters, we can find the centers also, we can find the two teters. Okay, teters, the teters mean the total sum of squares, right? Cluster means vector of integers indicating the cluster to which each point is located, right? Centers means a matrix of cluster centers. That means number of clusters we can form. Teters means the total sum of squares. Withinness means in a group or in a cluster, what is the variance among the elements present in a group. And TOT dot withinness means the total within cluster sum of squares. Between, as you know, that if we have 2 clusters, 2 different clusters, what is the variance between the clusters? Size means the number of elements in the cluster. Okay, this is the iteration one. This is the fault one. What is the error present in while obtaining the cluster analysis in a cluster? Okay, so these are the elements, or these are not elements, these are the attributes present if you are performing k-means algorithm upon a data set, right? So up to this we are clear. Then we can do what? We can plot the clusters. In the previous example, we have used which kind of functions? Can anybody say to plot? In the previous class, we have plotted, right? So which function we have used? That was clus plot. If you remember, that was class plot. Okay, so here we can use that is auto plot. That at the beginning of this session, in second session today, I told that here I will take example of the different data set and I will perform various other functions to perform the same operation. We have to import or we have to install other packages. We have to call the packages and will make use of different functions. So here we just used this select function. If you remember this, select. Okay, select keyword or not keyword. This is the function or this is the method or this is the statement that is used because we just imported these two packages. Okay, and we also used this. We also use the auto plot function. Previously, we have used class plot, and now we will use the auto plot function. So we are using auto plot function because we have installed this ggplot2 and ggfortify. So as per the various packages we have installed, they are providing us various facility to use the different function. Okay. So let's experience the benefit of the various plotting functions. So let we have, I want to plot the clusters. I have to use this plot, auto plot. Within bracket, I have to write km. Just say, tell me why I'm writing km here. I am writing my data. Then I am writing here frame is equal true. Okay. If I am just pressing Control Enter, you can see the graph or the cluster is now displayed. Okay, it is taking its level is 2, taking two variables. First one is km, second one is my data. We are giving frame as true, that means it is showing in a frame, showing in the frame the clusters, the points in the cluster. Okay, so two variables km. Km shows what? The number of clusters. Here we are applying k means algorithm on my data, and we are saying that I need two clusters. So the value of this, do you need how many cluster? It is now, it is now, it is kept in variable km. So here km is taken, that means I am saying that whenever you plot, I am saying to autoplot that whenever you plot, just give me two clusters, and which values will be considered? The values present in my data object. So what is present in my data object? The iris data set, and it has four columns. So four columns of iris data set is now there. So it is now being plotted, that km and my data. Okay, so let me zoom this. Okay, so you can see two clusters, cluster 1 and cluster 2. So here the red dots, that means the observations belong to cluster 1, and blue dots, the observation belong to cluster 2, and it has the frame true. That means it is written, it is being displayed in the frame. Okay, this is in another frame, right? So here these two categories belong to two different frames. That means you can see that it is pretty evident that these two clusters are distinct. Okay, these two clusters are distinct, there is no overlapping, right? There is no overlapping between the clusters. So cluster analysis in our example is now successfully deployed, that we have plotted the clusters, and we can see that we are getting two different clusters by using the auto plot function. And we can see that these two clusters are not overlapping with each other. That means the values that belong to cluster 1 only belong to cluster 1, and the values that belong to cluster 2 only belong to cluster 2, right? Okay, let me make sure that am I clear to everyone? Okay. Okay, okay. Okay, no issue at all. Okay, so in the tomorrow also I will explain the same thing again, then I will start the new session, right? Do I need to explain again at which part you are facing difficulty, Sylvester? Tell me again so that I can explain. Please write in the chat box, right? So that I can explain it again. Yeah, I can know that I am saying
Please,
so many
I'm
things. Okay.
I'm okay
See,
for now.
if you are okay. Okay. See, I know that in today in the same class I have two classes. It is scheduled two classes, and in two classes I have told so many packages, so many functions, so many things. I am just explaining. It may be difficult to means grab all these things so quickly. Okay, it may be difficult. So no, don't be worry about that. Just ask me at any point if I'm feeling any difficulty, and in tomorrow also I will just give a recap of what the things I have explained today. Okay, so don't be worry about that you are not getting all the things. Sylvester, if you want to ask me if I need to explain again at any point, please write that I need to explain from that point. So I will be clear that I will explain that again also. Please. Okay. You do one thing that you will get today's recording, then you just whenever you will listen that what I told, at the same time you just open your R Studio, run, pause the video and run the statement one by one. Okay, listen what I am saying, then run one by one. After that, if you will feel any difficulty, you can ask me, I will explain. Okay. So tomorrow also, today what I explained, tomorrow also I will give a brief recap that these are the functions. By this way, we can also use we can also create clusters. How can we plot the clusters? What is the purpose? Everything I will explain again tomorrow also. So I am asking for today, right now, if I need to explain at any point again. Am I now audible to everyone? Mohammed is clear.
Yes, ma'am.
Anas is clear. Yusuf, what about you?
Yes, it's clear.
Okay. Yusuf, are you there? Okay, Sylvester, what about you? At what point I need to explain again? If you say, then I will get these are the points that I should repeat. Okay, no issue. Do one thing that let me close the session, and in two classes today I have explained so many packages, so many functions, so many commands, that what are the use, how can we use, what are the purpose of using these packages and functions, everything, right? Then you do what? Cutting. Okay, so you do one thing that uh, just read just listen the recording very carefully and do practice what I told you in both the classes. Okay. And tomorrow at the beginning of the session, and I will explain, will brief about today's class. What are the packages, how we can do, how we can plot, what is the meaning of each and every statement. Or if you need, I can also explain one line by line